So this is ixldd5, probabilities using combinations and permutations. Something that actually gives me a bit of a headache, so I actually enjoy it, but I don't want to do it all day. So in yesterday's content, or in DD4, I talked about kind of what the difference between a permutation and a combination was. Combination, order doesn't matter. In a permutation, order does matter. Now the nice thing is IXL is very clear about when you're supposed to use a combination or permutation. They will say literally in such an order. So they're pretty clear about that. So don't have to think too hard on that. Now let's go back to this question. What is the probability that all of these comedians practice slapstick? When we do probability, kind of follow the general idea that probability is the number of ways an event can happen over the total number of possible outcomes. That's the general gist on probability. So when I look at this one, a lot of times you'll see me do the denominator first because it's always the easiest thing to do. I'm going to pick 4 comedians out of 8. So the real way is how many ways can I choose 4 of 8 comedians? It's going to be my actual denominator. I'm going to be dividing by the number of ways I can choose 4 of 8. In other words, this is an 8 choose 4. Now, in the numerator, I want all of them to be practicing slapstick. So I'm going to pick 4 out of 5. 5 perform slapstick. How many ways can I pick 4 out of 5? So in other words, 5 choose 4. It's kind of rough. But the numerator is the number of ways I can pick 4 from 5, which is 5 choose 4. And that's what I'm going to type in. There is a formula that I can do this by hand if I wanted to. I actually have zero desire to do it. So 5 math probability, choose 4. I'm going to be dividing that by 8. Choose 4. So 0.0714. They want this to the 4th decimal place. I'm at a 15. It's nice. I want to get to an 80. I would actually rather write this out than type this out. So I'm going to use this guy over here. I need a blank piece of paper. Well, this one's about Tristan. His friend's going to a water park. The park has 9 total rides. They're going to choose to go on 6 of them. All right, so one thing they're going to do is they're going to have 6 possible choices of 9. So when I do this one, I'm going to have a denominator of 9 choose 6. How many ways can I pick 6 of 9 things? Numerator here is that I want all of them to be water slides. Well, I'm going to pick 6 rides. 7 are water slides. 7 choose 6. Sorry, I minimized that, got it out of the way. That's the permutation. 7 choose 6 over 9 choose 6. So I'll get out my little TI-84 here. Turn it on. Let's see, we got math. Actually, sorry. Type the 7 first. Even on the new faceplates, you can type in the number first. Math probability. choose 6. Then is divided by 9 math probability, choose 6. Oops. You may. My divisor was in the wrong spot, wasn't it? Divided by 9 math probability, choose 6. Alright, so I got 0.0833. Alright, I'm at 28. Rack up pretty fast here. This one, this one has this word exactly. Exactly 12 or food. Pay attention to that. There's 14 total prices, exactly 12 or 2. So this one's going to be a little tougher. All right, first off, we're going to raffle 14 prizes out of a total of 17. All right, so that's my denominator. That's the easy part. I always do that first. There were 17. I'm going to choose 14. Now, in the numerator, exactly 12 are food items. There were 13 food items, 12 of which I'm going to pick. So 13, choose 12. And there's some that wasn't. There's 2 more prizes because I'm raffling 12 foods. There's 2 that aren't. So if I read the text, if there were 13 food items, there were 4 that weren't. The last 2 non-food items are chosen from 2 things. So it's kind of hard. It's harder setup. But I have to account for the fact that 2 things weren't. And we do that through multiplication probability. So I've got 13C12 times 4C2. The 12 and the 2, you'll notice they add up to 14, the number of prizes. And the 13 and 4 add up to 17, the total number of prizes, which is right there. So kind of make the jump. 12 and 2 add to that 14, 13 and 4 add to that 17. Maybe you see that. It does actually help make this easier to write it out as opposed to just sitting there and pushing buttons on calculators. But what do I know? I've said this numerous times. I'm a middle-aged math teacher. I don't know anything. All right, so there's the numerator. I'm going to divide that by 17, choose 14. If I make a mistake on this, it's probably going to be rounding. I got 0.1147. It's really easy to do. Especially if you're one of those kids who doesn't write anything down at all. Got it right, I'm at a 39, goal was an 80. I notice this one again has that word exactly. Let's see, there are 17 total bottles. I'm going to select 14. There's my denominator. 17, choose, what, 14? I want 12 of these to contain pink soap. It says in the text that 14 of them contain pink soap. So I'm going to choose 12 from 14. Now, there are 2 more things that I have to put into these buckets. All right? I believe there's 2 more things. Yeah, there are. There's 2 more things, and if there were 14 that were pink soap, there were 3 that were not. So 3, choose 2. Now again, 3 and 14 make 17, 12 and 2 make 14. See how the numbers have to line up like that? Kind of use that to your advantage to make sure you're setting these up right. So 14 math probability, choose 12. Going to multiply that by 3, math probability, choose 2. We're going to divide that by 17, math probability. Sorry I'm so hoarse today. Jaden Carter asked me if I was a little pony the other day, and that actually took me a minute to get. I don't think I actually figured it out until somebody said, "'Cause you're a little horse." All right, so pushing buttons in there, assuming I pushed everything in correctly. I got 0.4015. Notice I got to round that little 7, makes that 4 or 5. So 0.4015. I'm at a 48, 32 points to go. This is about Elijah. They volunteered at Children's Hospital as an art director. He bought 11 shirts for children to decorate. 3 are size small. He was in a rush to get to the hospital. He randomly grabbed 4 shirts in specific order. I want you to notice that this one mentions specific order. Because it mentions specific order, I have to switch over to permutations. So that's the big difference on this one. I'm going to switch over to permutations because they talk about order. All right. So instead of using C's, I'm going to use P's. That's kind of the gist of it. Instead of C's, it's going to be P's. Now, the first 2 are going to be small. Oh, hold on. Let's see. He's going to pick 4, right, out of 11. The denominator here is going to be 11P4. Get that where you can see that. There you go. There's your denominator, 11P4. The first 2 are going to be small. Well, 3 of these are small. All right, so 3P2. I'm going to turn around and multiply that by what's left. He picked, what, 4 shirts? There's 2 to go. And if 3 of them were small, 8 of them were not. So 8P2. Now, just like before, you'll notice 3 plus 8 makes 11. 2 plus 2 makes 4. This is why I'm telling you you should probably write stuff down. But again, fat, middle-aged math teacher. I don't know jack. Except math, apparently. I used to think that my elders didn't know anything either. Then I became an elder. They were smarter than I thought. 0.0424 is what I got. 0.0424. I wish I was half as intelligent as some of the people I met when I grew up. We got 50. I'm at a 56, so what do we got? 24 points to go. Colton and his stepmother wanted to start volunteering together. They found 8 opportunities online, 4 of which involved working with kids. It's nice of them to volunteer. They randomly applied to 5 of the opportunities in specific order, so we have that mentioning of specificness. That means we're going to use a permutation. What is the probability that just the first 3 of the chosen opportunities involve working with kids? All right, so we have a wall of text here. They're going to apply to 5 of 8. The denominator is 8P5. The first 3 are going to be about working with kids, so it's going to be something P3, 4 of which involved working with kids. Now, if there were 4 that involved working with kids, that means that there were 4 that did not. So 4P. You know, if I don't know what guts here, I needed 2 to make that 5, right? Again, those 2 add to 5, those 2 add to 8. Check it. For math, probability P3 times 4 math probability P2 divided by 8 math probability P5. 0.0429. Assuming I rounded right, 0.0429. 63. Probably got 3 more to go if I don't screw one up. Done good, hadn't missed one. All right, so after touring a coffee bean farm, Manuel impulsively, that means he just couldn't control himself, bought 13 bags of coffee beans. Of these bags he bought, 3 were filled with almond-flavored coffee beans. If Manuel randomly selects 4 of the bags to send to family members in a certain order, there's that wording, certain order, what is the probability that just the first 2 chosen of bags of coffee are almond flavored? All right, so order was mentioned. It's going to be permutations. I'm going to go ahead and put down 3 P's. May as well. I know I'm going to use them. He's going to pick 4 out of 13 if I read the text right. So 13P4 is the denominator. The first 2 are almond flavored, so I'm going to choose 2 from 3. Now, if 3 were almond flavored, 10 were not. Notice 3 and 10 makes 13. And to make this 4, 2 plus 2 is 4. I didn't even read the text, did I? No. Just kind of looked at what I'd written. So 3 math probability P2 times 10. If you're having a hard time sleeping, this is probably a good thing to put in your earbuds right before bed. Nothing will make you tired like a lesson on permutations, especially if you try to actually understand what's going on here. 0.0315. 0.0315. 69. It's one of y'all's favorite numbers. It's that and 420. Alan brought 16 bagels to school, 17 which are poppy seeds. If Alan randomly gives away 7 bagels to teachers, what is the probability exactly 4 of the chosen bagels are poppy seeded? So he's going to give 7 bagels out of his little package of 16. Now, notice it does not mention permutation anywhere in here. It does not mention an order. There is no order on this one. So this one's actually a combination. So we know what they're hoping is that you've done so many permutations in a row that you just want to do a permutation and you want to miss it. So be on the lookout for that. Pay attention to detail. This one is combinations. We're choosing 7 from 16. So 16, choose 7. Exactly 4 of these are poppy seed. There's 10 total poppy seeds. 10, choose 4. If he's given away 7, there'll be 3 that won't. Sorry. If he's given away, I completely screwed it up. He still has 6 bagels to choose from, right? And 3 of them will not be poppy seeded. And again, 3 and 4 makes 7, 10 and 6 makes 16. It's just a nice little check you can do. So this one was a combination. Going to do an NCR. .3671. One more question probably. It's going to suck. It's going to be like a 79, isn't it? As I scan this one, I'm looking for the wording order, and I don't see it. So it's going to be a combination. So he's going to pick 5 applications to submit today out of 27. So 27, choose 5. Remember, whatever I write is related to those numbers, 27 and 5. Exactly 2 are for retail. Let's see, I'm going to scan the text. There's 6 that are retail. The other one here, 21 or not. 21 and 6 makes 27. Not even going to look at the text. 2 plus 3 is 5. See, once you catch on to how it gets set up and how the numbers work together, it's actually quite a bit simpler. At least it is in my mind. And I feel like being as brain dead as possible today. So 0.2471 is what I got. 471. Brilliant, and I got my 80. Good. All right, so there's ixldd5.